Hello and welcome to another episode of the Proof of Claim podcast. I'm your host, Todd Price, and we're not joined today by my co-host, Anil Barrett, because he's out of action with a snivelly, sneezy nose. But we have today Brendan Lee here to join us to chat all things Bitcoin and deep tech about Teranode and script. So, normally I give a bit of an edification, and I guess, Brendan, you've been... Well, I joined the academy, and you were the sort of the OG of the academy, I think the founder there. And since then, I've learned a lot from you, and you're still my go-to guy for all of the little itty-bitty details. Whenever I'm getting stuck on something, you're the first person I ask about. How does this work? Or what am I doing here? What's the little bug that I don't know? Or what's the Endian switch or something like that? So I consider you to be probably my most immediate expert that I go to.
Helps I'm just down the road, eh?
Yeah. All things Bitcoin script. I guess I would say you're if not the most, well, second to maybe one or two others, but Bitcoin script engineer expert, and maybe even just
thanks, Todd.
Give us a little bit of a background there. I've heard some other people say that there's maybe a handful of Bitcoin script engineers that can write sort of fluently. What do you think about that? Is that a true statement?
Yep, I would say that that's an absolutely true statement. And in fact, I would say that the complete lack of tools being used out there really lays that bare. And I have some pretty good tools now, and I'm in the final stages of getting those ready to actually put them out so that more people can use them. And I know that's late. And Dave Case, you'll have to forgive me, mate. I told you I would get it out in about June, and I'm 6 months behind. However, the changes were really needed. It's much more stable now. And before I had this tool, I was developing the scripts in an Excel spreadsheet and actually putting whole transactions together with signatures and everything. And that was really complicated. But I could not find any tool in which I could properly do Bitcoin scripting. And, we have things like Escher, but that is a very different beast. That is a compiler or a transpiler or whatever you want to call it. And it does not allow you to code directly in Bitcoin script. You're using some other language, and then it's translating that into Bitcoin script for you. And the results that you get very, very wildly, depending on some change that you make in that parent language that you're using. So I'm coding directly in Bitcoin script, and then we've now developed a tool which we call Bitcoin SX, or Bitcoin Script Extended. And that is both a environment in which you can simulate transaction flow. So you can build a multi-transaction flow where you might initialize a smart contract, create some other outputs to spend, then once you've initialized that smart contract, actually start doing operations and spending those other outputs in to be used as tokens or other contracts or whatever it happens to be. But you can now create like a full structured flow with multiple transactions. You can jump in at any state and debug any input to any transaction and see how that spend is being processed, and find if there are problems there, see what they are, and really, it's turned into an exceptionally useful tool. It does lack a few things, and so that's what I'm in the process of putting in there now. So one of the things I'm really looking for is the ability to get a transaction in BEEF format. So that's the Bitcoin extended format that was developed by
background evaluated extended format.
Exactly what he said, not what I said. Background evaluated extension format, was that?
Yeah, I think so.
Extended
extension, yeah.
Whatever. BEEF is a cooler name. Where's the BEEF? And I want to be able to stick a BEEF transaction in there and then actually step through the whole flow of that transaction and see, if it's a transaction that you're unable to process because there's some kind of bug in it, whatever, it should be able to take you through that transaction and allow you to track that bug down and find out what's wrong. Because, usually it's you're doing something wrong on the input, or there's actually a bug in your script in the output that you're spending. So, this is the kind of stuff that you need to be able to do if you want to be a Bitcoin scripting engineer. You've got to be able to look deeply within the script. You need to be able to execute that script through all of its steps and see the state of the stack at each after every single opcode. And so that's what the tool that we've built does. And getting that out there I think is going to really improve people's understanding of how transactions actually flow, how they process, and get them thinking in new ways of how to do things. So
amazing.
Yeah.
And how are people going to be able to use that? Is that going to be a service you guys offer? Is it an app or what?
Yeah, there'll just be a website. So it'll be just bitcoinsx.io. There is a front page there now, but unfortunately it only allows a few whitelisted people to log in. But quite shortly I'll be opening that up, and anybody with a GitHub, GitLab or Bitbucket account will be able to log in, and using those accounts, and then your projects that you create, you'll be able to put them back to those repositories, and actually then manage that as a proper project with version control. So and you can also still do the local download thing, but I really wanted something where there was more strict version control, which we didn't have before. You just had to keep saving a new version onto your hard drive every time. Well, now you can actually put it back into a repository and be working directly from that repo. So
that's pretty mega.
That's coming soon. I haven't actually tested that. I've only done it, and it's not actually working yet. But that's what's coming very soon.
And how are you going about developing that? Are you doing it with yourself, or you got support from a droid?
I am doing it myself with support from my French friend who goes by the name of Claude. Claude's a bit of a boss, actually. So we've had a very good time, Claude and I, over the last what must be 3 weeks now, adding features, fixing things. So it was compiling. There were 400 and something errors when we built the project. Now there's 0. Migrated everything to TypeScript, added all these login options. The next thing I have to do today is I'm adding a bunch of extra features into the simulator. So currently there's no ability to set the transactions lock time or to set input version numbers. Those are things that I explicitly use in my smart contracts, and so I really want to be able to do that inside the simulation environment. So that's happening today after this call. That's what I'll be getting into. And so I really want complete control over the transactions in this simulator. I want to be able to set the input version number. I want to set the transaction version number. I want to set the lock time. I can set output satoshis and output scripts and all of that sort of stuff. But there's a few more bits and pieces that I still need control over to have that total scripting engine. But I'm getting pretty close. And then the next thing after that will be to add in that beef translator, and that'll be a bit of a different UI to the current script development UI, because it's just, you're not creating anything, you're just debugging something. So that'll be, we'll see how that goes. But it's very exciting. I could show you what it looks like.
Yeah, please.
Let me just
I'll be curious to see the UI, because for me you sort of it helps to have a UI, because otherwise you're kind of having to have a UI inside your mind's eye or something like that. There's a lot of parameters to have to toggle, and it'd be great to see how you're representing the arrangement of scripts and stacks and
All right.
toggleable things.
Can you see that?
I can see it. Yep. So that will be
all right. So the problem
color
I have
coded
is
color coded opcodes there.
now that I've opened it, I can't see it. What's going on here? There we go. Need to get to there. All right, I'm going to put that over there. So, can you see my mouse moving around there? Yeah.
Yep.
Okay. So we have a project open here. This is actually a fractional ownership contract. I'm in the middle of. I've just fixed a bug in it, and so you will see it does say failed script verify. That's for a very good reason. It's because the outputs in this simulator don't match the outputs that the contract is expecting, and that's because I've just fixed a bug that's been in there for a very long time, and it was never able to do that, and I just haven't been able to go back in and fix the simulation to actually match exactly what the contract wants. So it won't verify the transaction, but what it will do is so I can so I'll just give you a quick tour around the UI. So this is the editor. This is where you edit your smart contract. So each smart contract is in a project. We do have example projects. You can import a whole project. So a project might be comprised of multiple files. And then you can export your project, and that's literally just saves it locally. Within a project, you have files, and we have a very simple little file manager here. You can open files, and so I'm doing Sonic Stateful, which is a stateful contract. This is the language, Bitcoin SX, and so we actually have libraries. You import macros from your library files. Then this is our script SIG. So this is our unlocking script. And you can see this is a fairly complicated smart contract. We've got new owners, we've got new shares, new certificates, artists being specified. And then this little pipe here, that is signifies the division between our unlocking script and our locking script. And then our locking script, we have a bunch of data at the front. And then our entire script is just broken up into these simple macros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Then in the middle, we actually do something interesting. We're actually pushing all the chunks of our script onto the stack. And that's so that when we rebuild our contract state for the next state, we have all the pieces that we need there, and we can just chunk them together. And then at the end, we're essentially signing that our contract is exactly the way that we expect it to be. But what I'll do is I'll show you what these macros kind of look like. So this is our sxlib file. And so this is the language. So you can see it's kind of like shorthand opcodes. There's no op underscore prefix. But otherwise, it's exactly, all the opcodes are exactly as they are in Bitcoin script. But then we also have other macros. So you can see here, I've got a macro called administrative exit. Now, administrative exit is a way that allows me, so if there's a bug in that smart contract, I can send an administrative exit code into that smart contract, and it'll just unlock early without going through all of the conditional checks, so that I can then create a new output with an updated version of that smart contract that fixed the bug. And if I go into, it's this one, other sxlib, you will see administrative exit. So that's where I'm defining the macro. So I'm doing a pick of a value off the stack, I'm checking that it equals my administrative exit code, which is just XXX at the moment. I'm dropping everything I don't need off the stack, and I'm doing a check sig with a particular public key. And as long as you've sent me the administrative code and you've given me a signature that's signed with that public key, then great, I will let you exit early, overwrite the contract, do whatever you want.
I thought you'd do 4Xs since you're in Milton there.
Oh, that's a good call, Todd. The 3Xs comes because, and that's nothing to do with pornography. It's the 3 kilometers up the road from my house, there is a brewery that makes a beer called 4X. And so when I drive up Milton Road, I get a big giant neon sign, XXXX, with the flashing with a little man tipping his hat. It's been there for about, I think that brewery is about 120 years old.
Probably.
Yeah, it's pretty cool. And then I think it's Tuesday and Thursday, they make the beer, and the entire suburb of Milton smells like hops and I don't know, it's not a very nice smell actually, but
well, they're making 4X.
yeah, well, I don't mind a 4X on a hot day. If you've been toiling in the yard, it's quite nice to crack open a gold.
Yeah.
But anyway,
this is amazing. Yeah, really cool. So yeah, the colors are awesome. So when you said before,
the colors are really helpful because it means
cool.
it allows you to just scan through things really quickly and find them. And so what I'll do is I'll build that contract, and so you'll see. So this is where you're editing everything. Then here's what we call the expander. And so the expander essentially has the complete transaction with all of the data pushes, all of the opcodes, and it maintains the colors that are used in the editor. So if you know where you're going, it's quite easy. And then you can click anywhere in this expander and the debugger will jump to exactly where you just clicked. So if I go to click on the opcode, the cat before that #256, I can jump straight there. If I click on the cat before that 408ADAC, that I can jump to that. And that just allows you to jump quickly through the code. I'm going to make some improvements to this debugger that allows you to essentially skip unused code sections. Like if you do an if loop and then whatever's in that if isn't being processed at the moment, you've got to click all the way through. But I'm just going to make it so that it automatically jumps to the end, which will be very handy and much speedier to get through things.
And so those macros, when they come in, they just will bring in, say, like a dozen opcodes at once or something like that, or up to
or hundreds or thousands of opcodes. Yeah, so I've got some that are huge, and not only that is that the macros can be nested, so you can call a macro from inside a macro from inside a macro.
So it's pretty powerful way of building, hey?
Yeah. So I mean, this is how Forth. So the precursor language to Bitcoin script is an old language from the 1960s called Forth. It was invented by a guy named Charles Moore, who is not the guy who came up with Moore's law, but another Charles. I think that the other guy went by Chuck, whereas this guy's Charles. But it was used to align satellite dishes for telescopes and things, and then made its way into industrial stuff. And I think people would be very surprised if you go into a lot of old distributed control systems. And when I say old, I don't mean like not new. I mean systems that are built on top of systems that have existed for 40 years. You think Yokogawa, you think Foxborough, you think Honeywell. These control systems, they're still out there, still actively being used. They still use this language in the control blocks and things like that. So that's how I came into this, and then realized Bitcoin script was based on Forth, and thought, oh, well, I can definitely do that because I've spent so long using it in my previous career. But what we never had was a good editing environment, and I think this one here is a very good certainly for me, it does everything I need, and being able to see the stacks here on the side. So, as you're stepping through, let me see if I can find some alt stack action. I've got some here at the end. So I've got here, I've got to jump, I've got to click in here to the alt stack. So you can see that when you get stuff on the alt stack, it just divides this stack visualizer up, and then so the alt stack comes here. And there's really no limit to the size of things that you can push onto the stack. In this particular transaction, like if I go back to where looking about here or here. So this is our outputs for this transaction. It's a 22 kilobyte data item. I've had much larger, sort of 100, 200 kilobytes of outputs, and Bitcoin SX handles that really neatly. It does eventually tap out when the browser's memory gets too overloaded, but you have a lot of room in there, and we're going to work to make that even more flexible. But you can do a lot in 20 kilobytes in Bitcoin script, and or 100 kilobytes. I've loaded up several hundred kilobytes of data stuff in there, and it handles it really well.
What sort of fees do you end up incurring when you're in that sort of several 100 kilobytes or whatever?
Well, until about 2 weeks ago, it was pretty cheap. You could do 30 kilobyte transactions for 30 sats. But that's now about 3,000 3,000 sats, I think, is the going rate.
But still bugger all.
Still pretty cheap.
Yeah.
Still very cheap. So, you're talking, I don't know, like 1/10% maybe.
But then to do something like in the hundreds of kilobytes on other smart contracting platforms and such, that you'd be talking more than that, eh?
Pony up, mate. You're talking dollars, not sub-cents.
Yeah, so this is all conditional logic and that can be deployed still to support micropayments and control systems.
When I say 30 kilobytes, that's 30 kilobytes of actual execution. There's very little just data. There's no return output with just some picture hanging off the end. Like it's all executing stuff.
And so then if you're doing this over multiple transactions, because this is one script in here, that's in one transaction, and then you're chaining it, piping it into other transactions. How's that sort of being expressed in this editor? Or
okay. Well, let's just create a test project, and then we can we'll just reset this sim JSON. It should have reset, but it hasn't. So we can open this conversion and paste that there. There we go. That's better. So this is the basic contract that you get when you create a new project. You can execute that. The script is valid. You can see here, this is your execution. There's your signature. There's your public key. You can verify it. Sorry, that keeps popping out like that. Now we can say we want to add another public key check. So we're going to check sig, but on the first one, we're going to check sig verify so that we don't leave anything on the stack. And we're going to make the second one, we're going to make that pub key hash 2. And so now when we create this output, we need 2 public key hashes. and we need to select them as different public key hashes in our. So it's also got a full key manager in the back, and so you never have to tell it what the keys are. You just give it a key number, and it'll pull those keys off a big list that it keeps in the back. So
that seems like it's are you looking at connecting that up to something like BRC 100 interface, or
maybe
some kind of keyring manager,
possibly.
Yeah,
possibly. So now what we can see here is that we've got a script now that does 2 rounds of pay to public key hash. First one is the check sig verify, so we don't leave any stuff on the stack. We need a second signature and public key. So let's just, okay, so our first public key hash is public key hash. So we're going to use public key and signature. Our second public key hash is public key hash 2. So we're going to use public key 2 and signature 2. And what we need to do is in our the in here, we need to add some arguments. So we need public key, pub key 2. Whoops.
Mr. Wire.
Yeah. And actually we also need sig 2. And then that's going to be sig 2 is our pub key hash 2 is 1. So our sig is going to be 1. We need comma. We need a 1 for that. And then we need, so you'll see when I'm entering the JSON, see how it's underlining everything. I've added a little JSON error finder because it used to just say, invalid JSON.
Oh, okay.
And you'd have to search through line by line, and I had simulations that were like 500 lines long, and that gets really tiring. So now it just tells you with a little flash, little underline,
like a linter.
Yeah, exactly. Okay, so now we have pub key hash 0, sig 0, pub key 0, pub key hash 2 is. Maybe I should make that 2. So it makes more sense that sig 2 is index 2 and 2 and 2. And then we're creating a new vout, and we're going to have pub key hash. And we're going to have pub key hash 2, and we'll make that 2. Okay, so we should be able to test that now. And invalid JSON. Where is my invalid JSON? Debug beans. I've got an extra. I'm missing something. Oh, here we go. There we go. Done. Script is valid. So we can go back and check what that's doing. So there's our sig 2, pub key 2, signature, pub key. We're duplicating our pub key. So now we have 2 copies of pub key on the stack. We hash 160 the first one. We get our pub key hash. We equal verify. They're the same, so we're good to go. We check sig verify. That signature worked, so we can continue. We now duplicate pub key 2. We hash 160. We check it against the pub key hash with an equal verify. That's the same. We check our signature. Leaves us a 1 on the stack, so we're good, still good to go. And then we've just got a little hello world drop and some no ops, which are just part of that test script. And that's it. Our script is valid. We have passed, and we could then go on and create another transaction. So let's do that quickly right now. So we can create another transaction. So we've got our first transaction is just our lock transaction where we create our first output. Now, second transaction is unlock number 1. We're going to now create unlock number 2. I'm not going to change any details about it, except that I do need to change that which TX we're spending, because I'll just show you. If I leave that as 0, I hope this works because I haven't tested it since I finished all the upgrades, but it should tell me, yeah, transaction unlocked 2, V in 0, attempts to spend UTXO from TXO Viet, but it's already spent. So it's telling me I'm double spending. So I just need to change that to transaction 1. So now I'm spending this V out here instead of this one. And now when I build this, it should work. So there we go. Script is valid. And I can now go in here and I can choose to debug unlock number 2, V in 0. And yeah.
And this is where you're wanting to add beef so that each of these next steps in the transaction can carry its ancestry proofs and can be validated atomically as an interim state, or at any point, you're up to there and you're like, okay, we can still make sure that the next one can be validated with SPV because you've, sort of packaged the ancestry with every step in it.
Yeah, well, ideally, what I would be able to do is come in here and create like a beef transaction, and instead of having to specify the V outs and blah 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 blah, I would just go beef and put the whole raw transaction in, and then this would be able to give me the various data items that are in there, all of the opcodes, not necessarily as macros or anything like that, but it would be able to show me the execution of the transaction, and then I would be able to save that and go in and actually start to decipher what's going on. And so I can go in and actually debug. I can find very quickly where is the failure. So there's usually, it'll be some stack operation. You're trying to split something that's not big enough, or you're trying to concatenate something where there's nothing there, or you're pulling something off the alt stack and there's nothing there. Like, there's all kinds of ways that you can get tripped up, or especially before the Chronicle update, we still have all of these malleability checks in there. And so there's a heap of opcodes that you can't use to do things if the number that you're trying to do them on has leading zeros in it. And actually, this doesn't detect that at the moment. We've written it with Chronicle in mind, and because we actually thought that would be ready by now. But I guess that's a nice segue into the next thing to talk about there, Todd. I think probably everyone's seen enough of Bitcoin SX for now, and so
I reckon some people have seen enough. Others are like, I want to see more.
Others are chomping at the bit, mate. They want 10 times more. So yeah. But
is that going to be a free thing for people to use, or are you going to monetize it?
Oh, I'm going to monetize it, mate.
Good. I'm like, how do you
tap out of it?
So membership, or how do you do subscribe to it or something like that? What's the plan there?
It'll be like an account, and you'll pay, and I'm planning to have different levels of access. So there'll be a personal level where it's much lower cost, but you'll be limited to what you can do. So that won't have a lot of the features that certainly I've just shown you. And then like an engineering level, and that'll have full features. And then on top of that, there'll be an enterprise level. And the goal with the enterprise level will be to allow multiple people to work on the same project. And so have support in the back for people, essentially, through that use of Git, allow people to be working on different aspects of a smart contract and testing it and committing it back into a central repo to get something working.
Can they then alert you, Brendan, we need some help? Raise an issue to you.
Well, there'll be certainly support, but that'll be dependent on, it'll be very time limited, because there's only me at the moment, and obviously you'll be able to buy more support if you're having trouble actually finding a way to do something in Bitcoin script. That's certainly something that we can help, or I can help you with, but that will be a hourly rates kind of.
For sure. Yeah, exactly.
Yeah.
It'd be great to sort of do some outreach with this. I've sort of follow a couple of Forth communities, and there's the Forth subreddit. They're pretty active on there, and there's a Silicon Valley Forth meetup. It'd be pretty, I think, valuable to share this tool with some of those guys, because if we're looking to get people who can sort of wrap their head around this way of doing things, they're probably a good feeder pool to select some people from.
Yep. Yeah, definitely. And I mean, if you said, oh, you got to go out into the world and find the best people to train for Bitcoin script, that's going to be the first place I'm looking, is people who can do Forth, control systems engineers, people who have experience with industrial protocols, not web developers, not front end guys. They do not know what they're doing. And so, yeah, you need someone whose wiring is a bit funny.
Yeah. So I've been working with another sort of group, and one of the guys there has got a lot of experience with sort of control systems, SCADA networks, power grids and such. What do you think there's like applicability into? Do you know anything about SCADA? SCADA?
SCADA, I've done a lot of SCADA.
How do you think these two might work together then?
Look, I reckon there's a real case to be made, and I was actually speaking to one of our sort of shared acquaintances, AE, who we spoke to the other week, about this in London recently. I reckon there's a case to be made from a control systems perspective that, one of the biggest risks, and especially this is at like the grid infrastructure level, is that a lot of these old systems are very susceptible to man-in-the-middle type attacks. And there's a real case to be made that the entire architecture of how these control systems work can be overhauled and upended in such a way that instead of having a network pipe that exists between master and object being controlled, that you instead have the blockchain ledger, and that when the master device is issuing commands out to things that are doing stuff like switching grid level electricity around, or turning water on and off, or whatever it happens to be, that instead of sending a command directly down over a little internet pipe where someone can just come in and snip and pretend to be that service, that instead now the master is actually writing that instruction to a token on the blockchain and signing it using a key that is securely held, and then the device that is being controlled is actually just watching that token and waiting for that signature to appear, and then changing what it's doing based on that instruction, which now, instead of being a packet in an industrial protocol that's coming through some communications pipeline, is now a actual piece of logic that is executing in a blockchain environment, and actually giving it those instructions. And because now there's no pipe to cut, there's no way to inject those signals. The only way to actually take over that signal would be to somehow steal that key and get hold of that smart contract, and then do it that way. And I think there's a lot of risk in the current systems. They're very, very susceptible to being hacked. And I think actually, if we knew how, and this is my speculation, but I think multiple nations all sit at the ready to basically switch everything off in multiple other nations as like a war strategy, and they already know how to get into those systems. They're already all over it. And
is that like what Stuxnet was?
Yeah,
was that a system?
Stuxnet. Yeah, Stuxnet got into the SCADA, and I mean, Stuxnet. Look, ignoring what it did and who it did it to and who it was between, the way it was executed was actually quite brilliant. It got in at the SCADA level, and it disrupted the communications between the SCADA system and the actual system being controlled. It started telling the system being controlled to act in a way that would destroy that system, and by essentially speeding things up and slowing them down in a destructive way. And at the same time was feeding information back to the SCADA. So SCADA is synchronous control of data acquisition. That's the system that the operator uses, and they're sitting there and watching the system and going, "Oh, everything looks normal to me. Everything's spinning at the right rates and everything's going okay." But meanwhile, out on the floor, things are ripping themselves to pieces because the actual thing is tearing itself to shreds. And quite a clever way to execute that destructive attack. And you could bet, I would be almost certain that there's multiple very similar things that are already sitting there ready to go. And at a certain point, lots of stuff will switch off, and the people running the control room will say, "No, it's all running." But no, actually, in actual fact, everything's kind of, you can do very destructive things.
And that's because it's not an end-to-end protocol. So it's more everything's just transmitted over the wire almost in
basically,
clear text, yeah, there's no TLS or something like that on there.
Well, I mean, it's
added on after the fact or something.
It's like an onion layer kind of thing, but if you can be in the middle of the onion, everything's open.
And do that kind of transformation, say, like leaning right into Bitcoin to support it, like it would be quite an elegant way to transform it to a more secure system, because you can do it incrementally and prioritize certain areas first.
Absolutely, yeah. And I mean, you could even create a system where, so say you have these, you have a control layer which is in a control room, and it's talking out to devices that are in a paddock somewhere, and instead of that now being over the internet, you could essentially put a box on each end, and you could encapsulate that communications protocol inside tokens on a blockchain and transmit them via blockchain. That would be quite an easy first step of this. And before then, I think the next stage would be actually to go out and start replacing hardware components with hardware components that explicitly work only via the ledger. And that's when your control system in the control room, when the operator clicks, the go button is writing an instruction into a smart contract on the blockchain. That smart contract is changing state, and then the device that's in the control room is watching that smart contract, waiting for that state change instruction, and then turning on, shutting the gate, doing whatever it has to do based on that instruction. And now all you have to have is a uninterrupted connection to the blockchain ledger at each end. And you just have to be able to see when that UTXO gets spent. And so you're just subscribed to some overlay. You might be subscribed to 2 or 3 different services, all providing you access to that same overlay. And when you see that instruction come in, you can check that the signature is valid. And in fact, the miners are already doing that for you. They're checking that the spend is valid. They're validating the signature. The key is correct. That instruction has been sent from that operator to do that thing. And so, that's the kind of security benefit that we can have. And especially for this kind of public infrastructure. So now all of the history of what happened is being captured in that same smart contract, because you now have this immutable history of all of the things that were instructed to happen at that site. It's like a public record of public infrastructure.
And then you, like with the edge devices, say the thing on the gate or the particular meter or whatever it is, the actuator, that can be over something like a LAN or like
Yeah.
it can be offline
Yep.
almost, and the control system is the one that's connected to the node. There's
That's
still
right.
wrapping the internal communications between the control and the device with a Bitcoin transaction and check SIGs operations against, you know, the signature the keys that are able to sign on the device, and then it's doing SPV check from the control system, going back and saying, yeah, you know, keep sending these streams in, and we're logging them all. And so you don't even need you know, internet at the edge of every machine. Like
No, I mean, you could just have, you know, literally one little Starlink on the roof or whatever it happens to be, and then it's feeding out to, you know, you could have many hundreds or thousands of devices being controlled via that connection, and it's just like a site overlay, and it's holding site state, so it has all of the different tokens or smart contracts or, you know, logic blocks that control everything on that site in its state controller, and then it's just watching for new versions of those to come in, and so every time a transaction gets done that tells it to change the state, it will receive. Or on its own end, you know, there's always control, like automatic things that happen on that end. So, you know, if you have say the pond level goes over a certain amount, oh, well, you open the valve, and that control is happening automatically at the site. And so you'll have a little thing that's running there, and then when it sees that level goes over there, it's going to sign a new state into that valve and say, oh, the valve is open now. And even if that internet connection is lost, because you've signed that transaction and it's in that local overlay, you know, it will still work. And then when the internet connection comes back on, that transaction will get broadcast. You have the timestamp of when it happened, and all of that sort of stuff is still managed or manageable.
Yeah, that's how I've kind of thought about things. So the transaction itself it's a state machine before it's broadcast, and you can add inputs into that, and you can sign it in different ways under the different flags.
I mean, all these bozos out there going, oh, Bitcoin script isn't Turing complete. No, it very much freaking is. And, you know, if you could pull your head out of your bum, you would see how much potential there is within that framework to do this kind of stuff. I mean, you can manage a whole factory in a smart contract if you so wanted to. And it's, you know, it's just that you know, you believe the narrative, and, you know, pointing the finger at some pretty big names out there, you believed what you were told without actually checking yourself, and you're missing out on this opportunity to innovate at this exceptionally deep level with all of these protections that you could have, you know, against these types of extremely dangerous attacks. And, you know, I want to talk to governments about, you know, getting R&D going to put this into infrastructure, because, you know, I'm just one guy, and, you know, there's a few other one guy teams out there, and we need many more people coming in on this, and we need a big, like, infrastructure level R&D project happening to make this real, because you know, otherwise these, you know, there are these state level attackers sitting there ready to make everything go haywire whenever they like.
Yeah, that's a you know, an existential risk, isn't it, for the whole
very
economy? You know, ports shut down, energy grid shuts down.
Yeah,
like air traffic control shuts down. You're like, oh, now we're how are we going?
Yeah. No, it wouldn't take long for everything to go very, very pear-shaped very quickly.
Yeah, and there's not, as far as I'm concerned, there's not really any other competitive technology out there that can offer the same solutions to these big problems.
No, and not at scale, and not at low cost, and not in a way where, you know, you can do like the overlays and you can have those kind of self-controlled systems that just kind of tick along. And even if the internet does go out, well, as long as you've done your logic correctly, when you're designing a control system, it's always got to be such that, no matter what the operator says, or if the operator, because usually the operators are 500 miles away, no matter what the operator says, that the control system will never put itself into a dangerous state. And you have systems on top of systems on top of systems. And so you have a safety integrity level for each process and each system. And that safety integrity level will always be the last backstop in terms of, what can go wrong. And that might be something as simple like, so if you're pumping gas, and all of a sudden you have an overpressure event, and then you can't close the valve to stop that overpressure event. Well, maybe your safety integrity level system is firstly a set of gauges that are completely independent of all the other measuring gauges on the site. So if that overpressure event's happening because you can't measure the pressure here, well, you have another measurement over here, and it's a different technology and it's connected to a different controller. And then it's got its own valve that it can turn off, which is totally separate, totally, from all of the other valves. And then if even that doesn't work, then your last line of defense is there's like a little pressure plate, and it'll just blow a hole in that pressure plate and vent the air out into the gas. And it'll do that at a pressure that is low enough that it doesn't combust and immolate the whole site. But obviously, once you get to that level of failure, then everything's shutting down, everything's turning off. You've had a very, very dangerous event there. None of that stuff is going to go away. We still need all of that. But what we can have now is a way of controlling that and capturing the data, and being the control guy who's in a room 500 miles, 10,000 miles in space, wherever it happens that you are, when you're controlling that stuff, that control is not a point-to-point control system. Because at the moment, it's all point-to-point. And in fact, some of the projects that I used to work on, they would spend millions and millions of dollars running their own fiber cables from a control room in the middle of the city out through the sewers, out into the country, down the side of the road, digging trenches for thousands and thousands of kilometers, just so that they could have the security that they wanted over their systems. Now, we can do away with all of that requirement by implementing things in this ledger control.
And they're not losing it, they're not. Everything's just pseudonymous. It's just keys going on there, and their overlay has all
pseudonymous.
has all
keys
the semantics to it. Hey,
the overlay knows what's going on. Over time, if you tried, you'd probably piece some of it together. But again, you still can't do anything with it. And in a lot of cases, that stuff should be public. If you're the Wivenhoe Dam controlling the drinking water of Brisbane, everyone wants to see when you open the gate, when it was flooded, what's the level at the moment, how quickly is it going up. Why shouldn't that be done on the blockchain and captured in a way, in Australia, there's this controversy over the new Bureau of Meteorology website. They spent nearly $100 million with some glorified consulting circle jerk to give us a really crap website that hardly works. And my question is, well, in all of that process, what happened to the 150 years of climate data that we had, and how much of that got torched and is been modified or no longer available? Or
the new website
what's
sucks.
going on? Oh, the new website's a disaster.
It looks like just a weather.com or something like that. I like the old,
my goodness. The old one was
90s
great
style, I knew where everything was,
and now it's just this trash where it's it takes about 12 clicks to do what used to take 2 clicks.
And the data behind it, it's like what happened to that?
Well, where's that data? And this was I think one of BSV's biggest lost opportunities was Weather SV. Paul and the guys up in Atherton came up with such a really clever concept. The data was available. We could I think we worked it out. It was something like $75,000, and we could have logged every single available data point in the world for something like 25 years. But we couldn't get the funding for it. And so now that it's just whatever got funded by people, but it's a bit of a sad, but I think we need that kind of data integrity. If we're going to have big arguments about, well, what's the climate doing? What are we doing to the climate? And now you have these big companies coming in and essentially taking over all of that data. Well, they can then tell us whatever they like. We don't have any oversight of what that data used to be or how they've actually gone through the process of, because I look, when the tenders came up for all of this renewal, they were talking about, what you need to do is take these paper records that have been, handwritten records from these hundreds or thousands of weather stations and use AI to essentially read each page, capture the information and digitize it. Well, where did those original paper records go? And how did they digitize them? And do we have any kind of validation of how accurate their thing was? Or, have they done a funny business to make the trends fit a particular narrative?
But AI never gets anything wrong.
No, it doesn't hallucinate or give you wrong answers when it doesn't know.
How's your experience been with AI, like with Claude? I got you onto Roo. What was that, 6 months ago? And
Roo, look, Roo was the perfect first dose. Just good enough to get me going, but not good enough to actually do anything worthwhile. Then I think you'd already switched to Claude, and I kept hearing Claude was great, so I jumped into Claude. Claude is much more powerful than Roo, and I think, or Claude Code, because you can actually use Claude in Roo, but using Claude in Roo is still not as good as using Claude Code. Claude and way more expensive.
Yeah.
Even just using Claude Code, my wife is looking at our credit card bill going, what is this?
Yeah. I just downgraded because I've got less money coming in. I'm like, I can't justify that anymore. Well, I'm not sitting on there for the hours a day that I was,
I might be in the same situation in a minute. But for fixing up Bitcoin SX, Claude has been incredible. And I've taken what was a code base that had been worked on by really two guys on and off over 3 years, cleaned everything up, brought everything up to the latest libraries, migrated everything so it's one common language across the entire site, added a bunch of features. I'm working on adding a bunch more over the next couple of days. And, me personally, I'm not a front-end developer. I can bash out a HTML website, which is very simple, but don't ask me to use React components or whatever that even is. I suck. I can write a smart contract really well that does very cool stuff, but to build the API around that, I needed Claude, and that's where for me this really takes off, because it means I can now on my own do stuff where I needed a team of other engineers. Now, I on my own with Claude am not necessarily as fast as me and another engineer, because Claude does this thing where about every 20 to 30 minutes, it runs out of context and it has to compress that context. And in that compression, it loses about 90% of the information that you've given it over the last 10 to 20 minutes. And it often ends up making the same mistakes over and over and over again. And you have to be quite wary of where you are in that context. I've gotten a lot better at keeping the tasks much more modular. It was always fun to go, oh, Claude, I'm writing this thing, and it's going to do this, and it's going to do that, and it's going to do da-da-da-da-da-da. And you'd write out this whole 3 pages of stuff, and Claude would go, great, here we go, and kind of do some part of it. and then forget the rest, and then go, oh, it's all ready, and then you'd try and test it, and none of it would work. And
hard-coded values, mock values, and you're like,
and then you end up in a situation where it actually ends up taking you probably 5 times longer to fix that up and get it running than if you had just said, okay, Claude, here's the first thing. Okay, Claude, here's the second thing. Okay, now this. And so I've gotten a lot better at taking what I need and putting it in a document for me, and then just dribble a bit at a time of it to Claude and just go, okay, now this. Okay, now this. Or on the other side, so when I did the code audit on the Bitcoin SX website, I made Claude run that audit file by file, and made clear that it wasn't to change anything, and made clear that it was to write a audit output file, and after each small piece of audit, it would write all of the things that it found, and then go on to the next bit. And so that it didn't matter when that context was being compressed, it was keeping all of the information that it had found in a format where at the end of that, we basically cleared the context and went, okay, here's what you found in the code audit. We'll start at the top and just work through. And, or what we did actually was we arranged that list so that it was made sense, and said, okay, attack this task first. And boom, 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 boom. We just worked through a list of about 50 things, fixed, heaps of stuff up. And so once you start using it in that way, and the other good thing that you can do with Claude is code up sub-agents. So if you have a code base, you can say, oh, Claude, I need an expert in this code base. And what it will do is it will actually read that entire code base, create a complete context around that code base. Okay, this file does this function does this, it's used here, does all of these things. And so then when you want to come back and do something with that particular piece of the code, you say, oh, Claude, bring in the expert on the simulator. And straight away, you've got your simulator expert. Oh, there's this problem that's happening since we migrated to blah, blah, whatever. And, oh, yeah, okay, well, that's last time that happened. It was because there was a thing here, and boom, here's the problem. Okay, so instead of spending 2 or 3 hours trying to fix something up, you might get it done in 5 minutes.
It's all about those the parameters and the systems you can make on top of it. Like that's
right.
It's it's a new type of engineering, really. They call it prompt engineering.
It's a totally different
engineering. Yeah,
exactly. And it's really easy to burn heaps of time because Claude is overlooking some really simple detail that's right at your feet. And it's some setting in some file, and it doesn't matter how many times you tell Claude, go and look at the settings and make sure that they're correct. No, you need to go in and you need to put your eyes on it and use your engineering brain and go, there's the problem right there.
Yeah. And, why are you doing a script hash? Paid script hash or something like that. It always defaults to because BSV is a niche knowledge set too, so it always just regresses to
it regresses to BTC stuff.
And so you constantly, like, if you're not paying attention, it's going through and like degrading what you've built, or it goes back and you needed to tweak something that wasn't and it's like, oh, just convert that to paid a script hash while I'm here, and you're like, no, we already like solved that, and now you're just undoing it, and I don't even know you've undid it. It's messy. It's hard to, because I'm not a developer either. I have a bit of an understanding about these things, but
there is a good thing that you can do is you can tell Claude. So if you just put a hash, and you can type in something that you want it to remember. And I remember typing in hash. Remember, this is BSV. Everything is BSV here. There's no BTC. There's no paid script hash. And then it'll ask you, do you want me to remember that for just this project or forever? And it's like, you remember that forever.
Yeah, because, I'm never going to be coding.
I'm never going to be coding BTC stuff. And since I did that, actually, I haven't had that problem anymore. Which is, so it does work.
Right.
Sometimes you'll tell it to do something, or tell it not to do something, and you'll use that function, and then it will still just go and do that thing anyway, which is really annoying. But
have you tried to create any skills? So that's a new thing that just got released, where you can basically tell it, give it a bunch of documentation and say, create a skill around this, and it will read all the documentation and make its own skill or expertise. And
I have not tried that yet.
Yeah. So it's probably with all the stuff you've got,
probably worth giving it a go. I want to get Claude. I want to get Claude coding Bitcoin script, but the few times I've tried, I remember once I spent a whole weekend just trying to get it to do something really basic, and it was totally unable to do it. Like it's, and you'd be telling it, okay, you need to manage the stack. You need to be always aware, like when you execute an opcode, what's that going to do to the stack? Oh, yes, I'll monitor the stack. But then it would be very clear that it just was forgetting to do that.
Doesn't. You need a document or something which is the state manager of the stack, and it can evaluate that, because it can't hold a stack state in context while it's just grabbing the next word.
And before I had Bitcoin SX, just for my own mind, I needed an Excel spreadsheet.
Yeah.
And without an Excel spreadsheet to tell you what's on the stack where, and even an Excel spreadsheet where you are manually going through and typing that information in, which is what I was doing for every opcode. Here's what my stack is. Otherwise, I reckon a good engineer can get about 5 to 8 objects deep on the stack before they lose track, and they can maintain 5 to 8 objects for around 10 or 20 opcodes. If you're trying to build something that's bigger than 10 or 20 opcodes and use more than, like, let's say 5 things on the stack, you're not going to be able to do that in your head, no matter how good you are.
Maybe once you get a few macros, you can start to like go, okay, I've got a loop there, and that's a kilobyte or something.
Macros allow you to, macros allow you to do things a lot more quickly. Like, so say for instance, I have a macro that takes a time that's in like Bitcoin and lock time, and converts it to an ASCII string, which is day, month, year, and that's like 2 kilobytes of code. And at one point, you end up with about 40 things on the stack. But it's all compressed into one little word. And so as long as you have your Bitcoin time on the stack, you just go BTC to ASCII time, and boom, it just looks like one step.
Yeah, that's so that takes a lot of the cognitive load off.
Oh, totally. And so once you get a library of all of those sorts of macro functions, you can really start to do very cool stuff. So you can now create smart contracts where you have some ASCII text in there that's readable. So somebody, if they were to go onto the blockchain and look in what's on chain, they can see in the output number 2, oh, well, that's where there's a certificate of some kind, and created on such and such date. And that date is the corresponding date of the end lock time of that transaction. And so you can past date a contract, but it prevents you, the protocol explicitly prevents you from future dating stuff. Yeah. So you can, you can start to implement these kinds of controls over how things get created and how things, if you're distributing something. Also, you can set a rule in the contract so that the next state change, unless this guy signs here, if only this guy signs, then the date of the end lock time must be after this date. So you can't unlock this for 2 years unless this guy comes in and signs. And if this guy comes in and signs, then we don't care what the date is. But if it's only Bob coming in and signing, then he has to wait 2 years. And if he tries to sign and the end lock time is before 2 years from now, then no, and we're not going to allow that to be valid. But if it's been 2 years, he can come along and sign it, and that's fine. He can take that and do whatever he wants with it. But all of that stuff is very easy to implement.
They're like exit clauses in a hanging negotiation phase or something like that. Hey?
Yeah, kind of, almost. Like essentially, you can just you can handle any item that is part of the pre-image that you sign. You can then control. So you can control how many outputs are in the transaction. You can control what those outputs are. So you can actually push whole scripts into your smart contract, and then you can say, oh, well, when
Oh, Starlink's dropping out there.
oh, bro.
Yeah, we lost you. You said we can push whole outputs out into the script, and then Elon said, "This is the good stuff. Let's shut it down."
Yeah, cut them here. What's happened?
We're still on the call, still recording. Yeah.
Okay, but we just lost the video.
You just froze for a minute or something like that.
I can't see you at all. It's like my browser's. Hang on a second. Let me see if I can. What was I talking about?
You said you can push anything that's in the pre-image, and you said you can even put a previous script in there that's.
Yeah. Right. Yeah, so you can have, you can be saying, okay, so we're creating some sort of registry where we're having these kinds of certificates, and then the certificates must look like this, but then each time you create a new certificate, then the number must increment so that, you get certificate 1, then certificate 2, then 3, and then in the next round, it knows that it's already made 3, so it's creating number 4, number 5, and in the next round, number 6 and number 7. And then you can have multiple different types of certificates, and they can all have their own little registries where, they're all incrementing, or you say you're doing like some sort of company management master contract, you can create an invoice. Hey, you owe me this much money, and it's here on the blockchain, and it's waiting for the payment. And currently, obviously, the payment's going to be into a bank account or via credit card or something like that, but you're going to have some hook that says, oh, yeah, this payment has been made. And so now we can actually spend that output that we've created back into the master contract and generate a little receipt that says we've received this money from this person. And now we can actually have a totalizer, which is calculating the revenue and the incomings and outgoings over that period of time. And then it can have an audit function so that when it goes off at the end of the year, it recalls all of these actions that took place and, puts everything out. And you can really do, we have only just scratched the surface of what is possible with this scripting language and smart contracts. And, the one thing that I am really starting to feel urgency around is getting other people trained across the way, certainly that I do it. I'm using techniques that I've developed over several years that I know that nobody else is doing, but also that I know that I can't do the things I'm doing without doing it this way. And so I need to start training people on that. And, some of those techniques are only available through functions that we have embedded into Bitcoin SX. And so, that's what we really need to start getting people using it. So that's the goal. That is to get that out there as quickly as possible, but not for free. Sorry for everyone who thought they were getting free lunch. No, it's going to be monetized.
Good.
That's important for me too, because I have finite resources and I can't pay for that to just keep going on forever. And I'm not funded by the BA like some other people out there are. And as much as I would love to give it to you out of the goodness of my heart is a blackened lump of coal.
Yeah, that's how.
Yeah.
Most. You've done well to still be hanging in there. There's a lot of closed shops in BSV, so the fact that ELAS is still
it's
got a
it's
pulse.
like it's like I'm by the edge of a fingernail. It's like, you know, I'm Tom Cruise in Mission Impossible 2. Like, wow.
Well, hopefully this is, you know, a
But
bit of a
without
tick, you know,
without the sunglasses or the guns.
Yeah. Or the you know,
Or
the
the
rips
exploding
physique
messages.
that does his own all his own stunts.
Yeah, that's it.
Yeah.
Yeah.
Yeah, so I guess that's tying into like the education side of things, because, you know, from my experience, education's been stalled for quite a while, and really, like, I was reluctant to push anything that was the wrong way, but the tech didn't exist for what we knew was the right way. Now it does exist, but it's still, there's, you know, the people who understand, you know, BRC 100 and the correct sort of SPV way of doing things. There's only there's more of people who understand that than there are Bitcoin script engineers, but most of them who understand it are either maturing the tooling or building their own stuff. They're not saying, let's take a step back and create educational resources so that we can scale this, you know, knowledge or intelligence or something like that. So I think once you have this tooling, I imagine it could, you know, structured exercises. You could have a workbook that goes through and you build it up the same way you do with there's a book, Structure and Interpretation of Computer Programs or something, the Lisp one. It's like the seminal book for learning at least Lisp, but generally like computer science and ways to program. But
yep.
Creating something like that, or, you know, worksheets to start at the beginning and building something and building a loop and building these things. So I'd be really interested to, you know, work with you, because the best way to learn yourself, like see, you know, do, teach kind of thing is the real way to drive it home.
Yep, for sure. I mean, I think the type of person that we're definitely looking for in terms of designing Bitcoin smart contracts is the back-end engineer, someone who's done like either assembly language type stuff, or certainly who's worked with stack-based languages. Like, if you've never worked with stack-based languages, you've only worked with things like JavaScript and stuff like that. I think probably your focus needs to be on the front end side and the API side, because there are two parts to this, right? There's the smart contract, and all Bitcoin SX does at the moment is helps you to write that smart contract. Once you've written that smart contract, you still have to build an agent to run it, and that's like an API. So the way I build it is I have the smart contract that sits inside an API, and then you send that API instructions, and then it's a little robot that's sitting there controlling the smart contract and telling it, okay, next state we're going to add this guy and change this and move that and fix this and whatever. But you still have to build that. And so really, you know, for an effective smart contract engineering team, I think there's three skills. There's that Bitcoin scripting skill. Then there's that API skill. And, you know, part of that API is also database. You know, you've got to keep track of all of the transactions that you've generated. If you're creating certificates within that, or contracts or tokens or whatever it happens to be, you need to be tracking those, and then tracking all of the relevant data that is stored within those, so that when you want to use them later on, you can very quickly access that and pull that out and build the next transaction that you need and have it ready, so that the third guy, which is the front end guy, can bring that data out and show it to the people who are the ones instructing the API what to do. So you know, you're always seeking permission from a human to execute stuff. So someone has to at some point be presented on a screen with information that says you're trying to do X, Y, Z, and here will be the outcome of that action. Do you agree? Click sign. And they click sign, and then a digital signature is generated, and that transaction can go and take place. And so that passes through the API. The API generates the transaction, gets broadcast to the blockchain. API gets a response, puts everything in the database, and now you have that new state, and that front end can then update and present the user with the updated information. Okay, here's what we did. Here are your options from here. Because you know, a good smart contract won't necessarily always create the same thing every time. You know, I see a lot of people out there using smart contracts and they only do one thing, and every time that you do it, it just recreates the exact same thing. A really good smart contract doesn't need to do the same thing every time. It might be you might have to send it an instruction. Okay, set yourself up to do this. Okay, now do that, and then it will take itself back to like a blank state. Okay, now set yourself up to do this. Okay, now do that, and now go back to that blank state, and now set yourself up to do some other thing. And so if you're running like a big registry that, you know, you might need to add certificates at sometimes, or sometimes you might need to split shares or merge shares, or all these functions like a share registry might have to do, or add assets to the company, or you're merging with a new company, or you're diluting, or, you know, all of these things. You don't necessarily want to have the logic that does all of those things sitting there for every certificate, not being executed every time you spend the contract, because it's expensive to just have that logic sitting there not doing anything. But what you can do is you can have that logic broken down into its tiniest component, sitting there ready to be deployed, and then you actually have logic that goes, okay, we're going to do this in our next round. We're going to take this piece of logic and we're going to repeat it 5,000 times because we have 5,000 certificates in our contract. And then all of a sudden your contract scales itself and goes, whoop, okay, I'm now this big, and next time I do my instruction, I'm going to update 5,000 records to do that. And then so it does that, and then the next thing it does is it goes whoop, back to that like origin, very small, ready just to be told what it's doing next kind of state. And so that's where we need to get to. I'm still not there yet. Like, I'm still learning how to do all of that. But, you know, this is the tool that will get us there at the moment. Whereas the way I see everyone else doing it, it's kind of, they're just repeating the same thing over and over. And then the contract has to have everything in it all the time. And it's just not practical. It doesn't scale. And it's expensive.
And do you think with like Chronicle, how it's going to change to allow opcodes in the unlocking script? Does that, because like what I sort of feeling like could come then is one of those agents that sort of in an interim step where it might need to mint a certificate or something, but it only does it if another conditional's happened before that. It can basically create the next transaction, which is going to be available there to grab later. And then once it uses that and it expires, it sort of mints another one automatically. It's just sitting there ready to be grabbed again and put in from a later. Like, can you use transactions as templates or something like that can be sitting there?
You can, but that's not how I would do it. I would just have all of the script segments that you need, and then you just build it from the segments. And they're like saved in the transaction itself. Like, so so if I won't open SX back up again, but one of the things is that, like, about halfway through the script, there's an opcode, well, there's not an opcode, but like a function called push code data, and that just pushes an entire macro onto the stack as like a push data. And so I've got all of my script segments, and, you know, I've done ones before where it's not just constructing, reconstructing itself, but it's also constructing other outputs using separate other scripts. And so it's actually pushing those scripts onto the stack, so that when it builds the output state for the current transaction, So what it's building is its own next state. So that's the output that will be the input for the next transaction. And then it's also building all of the other outputs. So they might be tokens, certificates, whatever, little functions, receipts, invoices, anything. And so as long as it has the script that it needs to generate that thing, you just pull it out of memory and you build them up that way. One thing I can see that having the opcodes in the script sig would be useful for. So there's been a lot of research into threshold keys, and threshold keys give us a really good way of having privacy around who is within a key signing group. And so you can have a single threshold key that goes into literally like a pay to public key hash script, but that key might be a 5 of 1000 key. Now, to do a 5 of 1000 key using the check multisig opcode, you have to provide all 1000 public keys. Now, in a threshold situation, you just sign with the signature, but there's some calculation that happens at a higher level where you are combining the 5 slices of key. But my understanding is that you only need the 5. You don't need the other 995 that didn't get used to prove that it's a 1000. And so the advantage of having the threshold, the opcodes in the script sig is that you can bring the 5 slices into the script sig, and that you can show the maths for producing that slice and actually prove that those 5 keys. And then so maybe you have some published information about who the keys are, so we can now see who, or at least privately within the group of 1000, you can see who the 5 were who signed. And not only that, but that information is embedded on the blockchain as part of that transaction. So that's one particular application. I certainly know that Freddie, who created SX in its original form, and certainly I would put close to my own level in Bitcoin scripting. Certainly one of the best other guys out there. He has his own things that he wants to use it for. So he's got a token protocol that solves the back to Genesis problem, which he calls Bolt, which he will release in his own time. But part of that is leaning very heavily on that ability to calculate things in the script sig. And that's not available to us at the moment. And I think, as we discussed before the call, there's quite a dependency on Teranode coming out and being ready first, and then we will go back and get Chronicle done and get it in there, because at least I think that's the way I see it going, because otherwise we should have seen Chronicle by now. It was meant to come out in November, and then the date went by with nary a whisper.
Well, I thought it was meant to come out in August. I remember writing comms about it coming out in August.
In August, the can got kicked to November, and then in November they didn't even kick the can. It's just sitting there. So
it's not really that. I don't think anyone's hanging. Well, Freddie probably is the one who's hanging on it most. But
I want to see it because I'm sick of dealing with these malleability bug. Just get rid of it, please, for the love of God, get rid of it.
But they probably need all those. If you have the multiple consensus rules, and then you're trying to test all the Teranode edge cases with another set of consensus rules, and was this UTXO created under this one or that one or this one? It's probably pretty messy.
Yeah.
So you've been working on Teranode, part of the testing team or hardening team, or what's been your role there?
So my role has been to create a blaster. So the way that Teranode gets tested is that they set up a network of Teranodes talking to each other, and then they start to blast large volumes of transactions into that network and monitor how it deals with, assembling the blocks, how are the transactions propagating properly, are we how is the memory performance, blah blah blah, all these sorts of things, and trying to have a real world testing to then inform the build testing that gets done. So there are some really experienced and very excellent guys who, based on what comes out of that real world testing, then go and write tests for the actual Go build that execute every time we have a new version of Teranode, and they're trying to replicate all of the conditions that we find that cause bugs. So we might find that, we get a bug if we have, say there's two forks that get created, and this fork then becomes the shorter fork, but the node that's following it, when it tries to put its transactions back into the pool and then catch back up with the other fork, like somehow it gets into like a lock situation and can't get out. And then obviously they repair that bug so that, now that node can sort of back out of its own little chain and go and follow the rest of the Teranodes. But we can then have a test that recreates that situation so that, no matter what else we change in the future, we're always testing that, hey, this thing that was a problem once, it's never going to be a problem again. Or if it is, we're going to catch it immediately instead of releasing some software that, shows that has that problem. And so my role has been to create a blaster. So most of those blasters, they just use very, pay to public key hash, one input, one output transactions. They generate just big long chains of transactions and it's a game of numbers. It's how many transactions can we do in a particular time. What I've done is built a blaster that generates weird and wacky scripts that do, so like, for example, there's one that creates very huge memory objects and then does hash functions on them, and essentially trying to see what happens when you have these almost like attack scripts that are going to consume really large amounts of memory and compute resources in that validation engine.
Yeah.
And what happens to Teranode then?
So you can slow down some part, like you slow down data going through and staying in the pipe, like the evaluated environment, and then some other parts have moved forward 100 steps in a different transaction getting processed. What happens there?
Yeah, well, it's more like, you can actually cause parts of Teranode to crash. And then those parts, before they kind of get back up again, other parts will go wrong. And quite often I end up in a situation where my node is totally broken, have to reset everything and re-download. And it does get, it can be slow going. But through that testing, we have actually found some pretty and resolved quite a few pretty significant issues. And I'm looking to wrap that up. So my work at the BA is probably not going to go past the end of December. So looking to have all of that wrapped up into a package so that other people will be able to take that and do similar sorts of testing using what I've created, with Claude's help, of course, in their own environment or on the Terra test net or even on the main net if that was what they wanted to do. But it's
so it seems, I guess, with the sort of Teranode, would you say that it is like imminent? Is it, do you feel like they're closing up a lot of these things, or they're just still presenting? Like what?
I would say it's very close.
Yeah.
the people at the board level had set some goals. I think we're imminently going to achieve. So they had goals for the end of the year. I think we're going to achieve those goals before the middle of December, which is great. And those are around like a particular performance level for a particular amount of time using a particular set of hardware. And what's great is that, we've gotten back to where we were in the original proof of concept level, however, with tons of extra layers of checks and protections. And like, it's not just the simplest, most happiest path. We now can handle every kind of transaction. We can handle big, small, whatever it happens to be. And we still have that extremely performant system. So, it is ready to scale up to, certainly hundreds of thousands, millions of transactions per second as quickly as needed. And hopefully then, we really can start to see the miners coming on board and creating their own optimized versions of these services. So, because I guess the thing with Teranode is that it's 2021, I think, or 17, or however many it is, like different, completely separate services. And all of those services need to work together. And this Teranode is really the first version of all of those services, and literally just get it working.
No optimizations.
Very few optimizations, and get it out there. And one of the things that keeps coming up when we have the meetings is like, oh well, we could optimize this, but it's really like, look, that's not the job. The job is just to get to this level, and then push it out there, and then it will be I think a good thing for all of these engineers who've been working on these projects is that as the miners come in and they want to start optimizing, these will be the first guys who get picked up and taken into those roles.
Do you reckon it'll stay in Go? I've seen some people do some comparisons between, say, Go and Rust, and that maybe you could get it. Not talking about Roy, but I'm talking about other guys who've said that Rust would do a significantly better job at
certainly on my no comment on the different languages and how they perform. But the great thing about Teranode is you've got 21 different services, and all they are to each other is an endpoint. And so it does not matter what is behind that endpoint, what language it uses, what database, what hardware, what anything. You can take any single one of those pieces and go off and completely re-engineer it. You can put it on an FPGA, if you want. And
make an FPGA for the check sig operation, like Peter Verizon was talking about.
Exactly. There's a million ways to come at the problem, and this is really just setting the stage. This is the shape of things. This is the architecture that is needed to propel Bitcoin from where it is today into 100 million, a billion transactions a second. And make no mistake, the Teranode that we have today does not resemble in any way, shape, or form the Teranode that does 100 million transactions a second. There is no piece of the Teranode of today that is the same in the Teranode that does 100 million. From a hardware perspective, from a software perspective, everything will be chopped up, rebuilt. But
maybe the endpoints stay the same.
It is those endpoints. It is those elements. That is what will stay largely the same. We now have this endpoint that does this part of the job, this endpoint that does this part of the job. And because they are all engineered around a fixed protocol, and that's never going to change. Those endpoints, really, they don't need to change either. They just need, optimization. And so in terms of the UTXO store, currently it's just putting everything in a big monolithic database. But over time, you're going to need something where the most recent UTXOs need to be really easily accessible because they're the ones that are most likely to be spent. And then anything that's more than, say, I don't think it'll be like days old. It'll be like, well, so you'll have capacity for, say, 50 billion UTXOs here. And then the oldest ones will be being shunted out into the next layer, and that will have capacity for 500 billion, but it'll be a bit slower. And then the oldest ones will be getting shunted out of that into some like archive. And then for the people spending the UTXOs, it will be, well, how old is your coin? Do I take it out of here, which is fast and cheap, or do I take it out of here, which is a bit slower and a bit more expensive? Or do you need me to go and get it out of there? Because that's dusty cobwebs, go find it in an archive. Yeah. And, I want $5. If you want to go spend that, that's going to cost you. And so that will allow miners to really start to set that fee agenda and really exert much more control over the work that they're doing to validate your transaction and charging you for that properly, because sats per kilobyte is the most dumb, regressive BTC way of doing things that you could possibly come up with. Like when I send a smart contract that's 300 kilobytes and you have to execute 300 kilobytes of logic, why does that cost the same as the guy who sends a 300 kilobyte cat picture with op return? Because the amount of work that you're doing for my thing is like 1,000 times more.
Yeah.
But you're charging me the same amount.
Yeah, the rig basically doesn't even switch on to put the image into the database.
No. Yeah. It goes, hey, that's an unspendable output in the bin.
Yeah.
It doesn't even hold on to it. Like it just goes, get rid of it. So it is what it is at the moment. But this was one of the things I pushed a bit internally at the BA, but they, and I think rightly, their pushback was, this is how miners do it today. It's up to miners to go out and develop these new systems. So for any miners out there who are interested, I have written up like a bit of a thing. If you go into the Teranode repo and look at the discussions page, there is a bit of a thing there about what I think that could look like, and would love to work with you on it. But yeah, I think, that's further down the track. We need transaction volume.
We need transactions first. Yeah. Where are they going to come from?
I think there's a lot of identity stuff happening in the world at the moment, and I think if the Teranode group can get adoption of their identity solution, that could very quickly start generating many millions of transactions a day. But they have to get that institutional buy-in, and I think probably it feels like they're struggling a bit to get past maybe some stigma around the technology. The good thing I'm finding is that quite often now, the people that we're talking to, they couldn't care less about the stigma. They just want something that works. And when you put it on the table, apples to apples comparison, they look at BSV and go, yeah, there's no question that's what we're going to use, because it's 500 times cheaper than the next cheapest thing. But not only is it 500 times cheaper, it never goes down, and it's got this full flexibility. The thing is, for it to have that full flexibility, we need 100 more guys like me and Freddie who can properly code up a smart contract, and we just don't have that at the moment. So this is what I want to get happening. I want to get people training up in these techniques. So for me to do that, I obviously need to get Bitcoin SX out into the world properly, and with some educational materials built around that as well. So yes, lots of work to do, and it's a lot to take on when you're just holding on by the tip of your finger. As you would know, Todd, like, being in BSV, you're not here for the money, I tell you that.
It's just so much fun being poor.
Oh, so much fun being poor and having all your friends and family scream at you for being an idiot and persisting with this madness. But I think you and I
can't shake it.
yeah, you and I both know in our heart of hearts that this is the only technology of its type that actually has any kind of potential future. And if it's not BSV, whatever it is, we haven't seen it yet. And so that to me means that it's BSV right now, and I'm here to just continue working on this until it's either very clearly not BSV or it's BSV in a big way. Yeah. And hopefully, if it's BSV in a big way, then you and I will both be fully involved in a full-time way, being correctly remunerated for that. And
and if it isn't BSV, anything that can do what BSV can do is going to face the same,
totally
15 years of obstruction to get it. Like, it needs to be stress tested. It needs to demonstrate its anti-fragility to show that it is a competitor, even in completely like adversarial circumstances.
Yeah,
it just keeps chugging along, which is a testament to how well designed it was from the beginning, that it can
the very beginning.
It did need it needed someone to come in and sponsor it, and tons of respect to Calvin and Craig and the guys who picked up that task and got out the checkbook to make sure that it had some funding to build this Teranode, to coordinate the teams that built the open source stack. I don't think without that kind of sponsorship, and we were just simply like an organic community trying to push against MasterCard and the incumbents, it wouldn't have been possible, So it's all well and good.
You could not open source develop Teranode.
Yeah, too many. It needed like vision. It needed a chief engineer.
Open source projects are too easily subverted, as I think we can see with BTC. It's open source. Anyone can come and work on it, but really that's not the case. You can only get your changes into the code if you kiss the feet of the 4 people who control that repository. And if you're not doing explicitly what they allow you to do, your changes are never going in. Like, it's a really sad situation that they have over there. And, it's interesting. I had a conversation with a guy last night. He's saying, "Hey, Brendan, you could make so much money if you would go over to BTC and try to solve these taproot scripting problems." They're trying to find ways of doing shit that we do in like 2 seconds flat, using taproot. And I said, "Oh, look, I looked at this a year ago, and you're fighting against the system that's been explicitly engineered to prevent you from doing what you're trying to do." And this is like an Escher staircase. It doesn't matter how many times you go around, you're never going to get to the top. You're never going to find a solution. And some of the solutions that I was reading about, it was like to execute 32 bits of logic in this taproot scenario, you had to create a transaction that had a 4 megabyte script, and that was as big as you could do in one block. So your transaction had to take up a whole block of BTC, and that got you 32 bits of logic that you could execute. And it's like, why? Firstly, that's not practical. You're never going to get that transaction on the blockchain, because unless you pay $1 million. Secondly, like, what are you even going to achieve in 32 bits? And it's like, oh, well, you need to do like 35 of those to do like one instruction. And it's like, okay, so you're going to consume 35 full blocks of BTC transaction space to execute your taproot script, which is going to build upon itself 32 times to execute some instruction. And all that instruction is, oh, we're burning some funds. And it's like, what is going on here? This is the craziest stuff. And anyway, I said, look, if they pay me enough, I'll go and do it. But it's like, I don't think it can be done. You know,
they'll make one transaction and then, or one set of 32 transactions and all the funding's dried up.
They've done everything they can to prevent you from doing what you are trying to do.
Yeah.
So what do you
going to succeed with his OpCat endeavor? Of
course not.
Yeah. It's more it's more like sowing dissent rather than it is actually going to get an outcome.
Yeah, he's just trying to agitate.
Do you think any of these guys that are working in such a roundabout way and are actually, you know, understanding it at least enough to realize to get the 32 bits you need that like, are they valuable resources to get using ScriptSX and go, what? I can just go
potentially. And you know, that would be kind of, certainly I wouldn't mind trying to draw from that pool. Look, I'm gonna stick my head in and look around and see what I can see, because you know, maybe they're spending 4 megabytes to do 32 bits of logic because they're not good at scripting, and maybe I can find a much more efficient way. I don't know, you know, I haven't really looked at it in any kind of seriousness, because it's such an unserious project to work on. Like, seriously, guys, what are you trying to do here? You know,
it doesn't make much sense to me. You're sort of like, what's going on here? Because it has to purely exist in a speculative domain, because there's no real utility for it other than underlying stuff that has a ridiculous price, like the
all
images.
The only thing they're going to get to is they're going to have some funds locked up in a pay to script hash, where that script is a totally unspendable script. And where do you go from there? Like, you know, and not unspendable because it is an unsolvable script, but unspendable because the conditions that is needed to actually spend it, which is this multiple chain of like 4 megabyte transactions, is not never going to be able to be achieved on BTC.
Maybe it, you know, with $50,000 of fees or something like that, you might get to run it 2 or 3 times in the history of BTC, you know?
You would need a miner. You would need your own miner that you could control to reject all other transactions, and that's really the only way that you'd be able to get your block in with your thing. So I don't know, like, just seems wacky. But look, I think at a certain level, it'll be interesting to interact with these guys and say, hey, can I just show you, look how easy it is to do what you would like to do when you have these 5 opcodes that you don't have access to. Opsplit, opcat, you know, really those 2, they're the main ones, like split and cat. Proper op return, not the stupid fail everything op return. And, you know, I think the other ones are all more like just, you know, 2mul and
optimizing just a multiplication.
Yeah, Boolean ands and things like that. Like, even Boolean and is pretty useful. I use the Boolean and function a lot in my smart contracts. But you just they just don't have them.
So they have, when you had the pipe in ScriptSX, is that an opcode separator?
It technically it does get turned into an opcode separator in the node when the transaction executes, but the transaction itself does not put opcode separator in there. But it does get put in there when the node reconstructs. So when it takes the locking script out of the UTXO and then sticks the unlocking script on the front, it inserts an opcode separator in the middle.
So you don't put that in yourself between in the script or the raw hex or something.
Oh, if I'm using opcode separator in the script, I just type code separator.
Yeah. Okay.
I don't remember. I think probably the pipe does work as well, but I just prefer to use the text because then it's explicit.
Mm-hmm.
Pipe, it's very easy to look past a pipe.
Yeah, for sure. Yeah, you got to find that balance.
Code separator comes up. It's got its own color. I can find it very easily, but really, I only use it right at the end. So I always use code separator because when you're constructing the next state, when you're constructing your script, your signature pre-image, you don't want to need to reproduce your current state. You just want to have some tiny little thing. And I just have code separator, checksig verified, checksig verified, checksig, because I have 3 signatures in that particular smart contract. And so my whole script code for my pre-image is 3 bytes long. And that's what code separator does for you. It's insanely useful when you do things the way I do it. Like,
right.
Just cuts tons of space.
I need to do some script worksheets.
Yeah, well, we can jump on and I can show you a couple of bits and pieces after this call. But I reckon let's not bore people too much. With our inane back and forth, Todd. Let's.
No, it is a good idea. I was looking at the time, and we've been a great chat. So, super appreciate you coming on and sharing that. Around hit the mark. I think. I think we covered. We could open up a whole other can of worms on some other stuff, but say that for another chat. So thanks a lot, Brendan. Maybe if people want to find you, what's the best way to get in touch with you?
Look, if you want to, I'm just Brendan _Lee _ on X, and just my DMs are open. You can always just send me a message. Or if you are not on X, then I'm also on LinkedIn, but I don't go there very often, so expect a slow turnaround. Or if you contact me through the ELAS website, that's also a bit of a roundabout trip, so we'll take a few days. The quickest way to get in touch is on X, or if you're a good friend like Todd, you can call me on my phone, but I'm not handing that number out, so no. X is probably the easiest and certainly the fastest, and you'll get a response from me, quite often immediately, or at least, within less than a day.
Well, you saw it, folks. That's if you want one of the world's leading script engineers, probably the, or maybe there's another guy that's got you covered.
I don't know about but in terms of tools and stuff, I reckon I got the best tool.
You're probably
certainly the best one I've seen by a very, very wide margin.
And you're probably the most leading one that's looking for things to be engaged with. You're available now. So
available now. But that could change very quickly. So I do apologize if you show up. And I'm not available. It's always changing. So got some super cool stuff that we can do. Certainly a lot of things that we're always busy improving things, developing new techniques, and love to apply them to your project, whatever that happens to be. Get in touch. And thank you, Todd.
Brilliant.
I appreciate your time.
Yeah, we've had a great chat. I love when I get to speak at this depth about stuff and just learn. I spent 2 hours learning basically, which is really good. So thanks a lot. Hope you enjoyed it, everyone, and we'll see you next time. Adios.